Hello, my name is Sharan Kumar and I am from RY40 and my metric number is 191382078. So today I am going to give an explanation on the Lab 2 operational amplifier, that is comparator and summing amplifier. So first of all, the objective is to demonstrate and investigate a comparator circuit and also to demonstrate and investigate a summing amplifier circuit. So this is the introduction here. You can see non-level detector and also the formula for it. So the components that we used for this experiment is resistors 10 kilo ohm, 2 kilo ohm, 1 kilo ohm and also 4.7 kilo ohm. And we also use DC power supply, function generator, oscilloscope and breadboard. So as for the first procedure, comparator zero level detector. So to investigate an op-amp used as a comparator for a zero level detector, connect circuit in figure 4.1. The small numbers in the diagram correspond to the integrated circuit chip's pin number. So this is the circuit that we need to build in multisim. So as for the next procedure, it is to create the comparator non-zero level detector. So to investigate an op-amp used as a comparator for non-zero level detector, connect the circuit in figure 4.2. The small number in diagram correspond to the integrated circuit chip's pin number. So this is the circuit for non-zero level detector. So you can see there's a table here and also the procedures for this non-zero level detector. As for the third, we need to find out the summing amplifier. To investigate an op-amp used a summing amplifier, connect the circuit in figure 4.3. The small numbers in the diagram correspond to the integrated circuit chip's pin number. So this is the circuit for summing amplifier. And this is also the table that was given with the values of resistors and also the procedures for this test. So here it is the zero level detector. So the input in front here and the output is basically here. So now we're gonna simulate it. So okay, it's moving. So what's gonna happen now is when the input reach at 0 volt, the output will go to the maximum voltage. So right now there's a little bit of fluctuation, probably due to the offset of OMP, but theoretically it is a state of exactly at 0. So it's gonna be at maximum voltage when it's not at 0. So over here it's gonna be the lowest, the minimum voltage, so that's the zero level detector for the comparator. Okay, now we're back with non-zero level detector. So it's almost similar to the previous, with only different that there's a resistor in the front and also input is over here and output is here. So we're gonna start with the volt resistor of 4.7, so which is same as this module. So let's start with 4.7. Right, so we're gonna simulate it. This is for the non-zero level detector. So this is the simulation here. So yes, you can see there's output and also input. The output we get is maximum voltage and it reached to that maximum value, so that the voltage of Vref, voltage reference, so in this case when it's 4.7 kilo ohm and 1 kilo ohm for the R2, so we get the voltage reference which is 1.754 voltage. So as you can see, the output result here when is reached, let me show you over here, and here's the y-axis. So here it's reached to this level at C1, so it's 2.8. I mean, this might be an error. So the waveform is quite, so theoretically it's at 1.7, so the output will be maximum, and outside the range of 1.7, which is lower than 1.754, it's gonna be maximum. So following with that, so I'm gonna keep showing this as the R1 decreases, let me decrease to 2 kilo ohms. So when the resistance decrease, like I'm going to decrease, so the voltage reference is also decreased. So right now it's 2k to 1k. So we can get that the voltage reference is 3.333. So the output voltage is getting the square by 4 and getting smaller when it's 3.3. And it's going to be maximum. So since the maximum is 5 voltage, so 3.3 to the 5 voltage is quite small. So as that, the resistor keep decreasing. At one point, if R1 and R2 is the same, so basically the voltage reference is already 5 voltage, so the maximum for input is also 5 voltage, so there's no voltage above the 5 voltage. As the result of output will go to the minimum, so most lowest voltage in this case is negative 15 voltage. So let's continue to the next one. Okay. So this is summing amplifier. So this is the circuit diagram. So it's the output for voltage 1 goes for R1, and the volt for voltage number 2 is R2, and this is the RF resistor reference for the summing amplifier. Okay. So the concept is that the output voltage is actually the sum of the input voltage after multiplying the input, and it's all multiplied with the gain factor. This is the simulation for summing amplifier. Okay, for the board. So we move from the first one. Okay, RF is equal to R2, so uh, we increase it to 10. So the graph, so basically when is all the resistor R1, R2 and RF is all the same, the output voltage will be the sum of the input. So since the RF is equal to R1 and R2, so the total will be negative 4 volts. Here shown here, theoretical calculation. So this is the formula over R1 multiplied with the input voltage for input voltage. So V1, and this is for V2, so that's more we're gonna increase to V3. So the output voltage seen here, shown here, sum is negative 3.976, so almost similar to the theory just now. So what happened if the R2 is decreased to as the sum of, basically if you change the voltage as the resistor here, you will get the sum, it will be different. So right now the output has changed to negative 12.003. So my calculation is, since y I get negative 12 is here, you can see here this part, so 10k divided by 2k multiplied by 2, so we can get equal square 10. Over here it's already 10 volt input, so that's why I get negative 12. So let's move for the question section. So what do you understand about summing amplifier? The summing amplifier is another type of operational amplifier circuit configuration that is used to combine the voltage present on two or more inputs into a signal output voltage. As for what happened to output if the frequency of sources is decreased to f3 kHz, briefly explain. So as for that, the output voltage still remained the same as 3k. I already tested just now. So the only changes is the time. So when the frequency increases 3 kHz, time taken to complete for one cycle decreases. So, next for the discussion. During the experiment for zero level detector, as input waveform is above zero voltage, the output will goes to the maximum voltage, so the output will form a square wave. For the non-zero level detection, the output from maximum voltage square wave when the input reaches to certain voltage. The voltage is called Vref. So when the Vref is larger, the output square wave will be smaller. If the R1 and R2 is the same, the output will be at the minimum. As for the discussion, during the experiment for summing amplifier, the total input will always be 0 voltage before entering the op-amp. The output of the waveform is the total sum of the voltage input by the gain factors of the input resistor and the reference resistor. So that's all for today. Thank you.